Stoichiometry. When reactants combine to form products, their masses must be equal to balance. Stoichiometry is the study of their masses before, during, and following the chemical reactions, according to the law of conservation of mass. Since total mass of reactants in the left side of an equation is equal to the total mass of the products in the right side of the equation, if the amounts of separate reactants are known, then the amount of the product can be calculated. Conversely, if the amount of products are known, then the amount of reactants can be calculated as well. The number 2 preceding the reactant oxygen and the water is the stoichiometric factor. Thus, 1 molecule of methane, CH4, combines with 2 molecules of oxygen, O2, to form 1 molecule of carbon dioxide and 2 molecules of water, H2O. Matter is not released but conserved in a chemical processes, and calculations involving distribution of mass in reactants and products are based on a mole. A mole is a standard unit for measuring large quantities of atoms, molecules or other particles. 1 mole is equal to 6.02214076 multiplied by 10 to the power of 23 units. This is called Avogadro's number. 1 mole of carbon-12 atoms has 6.02214076 multiplied by 10 to the power of 23 atoms and a mass of 12 grams. 1 mole of oxygen also has the same number of atoms as carbon-12, but it has a mass of 15.999 grams. Thus, oxygen has a greater mass than carbon. In solution reactions, the concept of molarity is used. Molarity is defined as the number of moles of a solute in a liter of solution. The reaction between methane and oxygen to form water and carbon dioxide and their quantitative relationships is called reaction stoichiometry. For every mole of methane combusted, 2 moles of oxygen are consumed, 1 mole of carbon dioxide is produced, and 2 moles of water is produced. Atomic weights are related to moles. The ratios derived from stoichiometry is used to determine quantities by weight in a reaction described by a balanced equation. This is referred to as composition stoichiometry. A chemical reaction of the reactants with their masses are required to make different products. Burning fuels, making glass and pottery, wine, beer, and cheese involve a chemical reaction. The atoms in reactants are redistributed in a chemical reaction to form new substances. Iron and sulfur react to produce iron sulfide. Chemists ordinarily work with weighable quantities of elements and compounds. For example, in the iron-sulfur equation, the symbol Fe represents 55.845 grams of iron, S represents 32.066 grams of sulfur, and Fes represents 87.911 grams of iron sulfide. In a chemical reactions, the bonds between the atoms in reactants are broken, and the atoms or pieces of molecules are reassembled to form new bonds. This results in energy absorption. If the energy is in the form of heat, then it is endothermic. If energy as heat is evolved, then it is exothermic reaction. The formation of water from hydrogen and oxygen is exothermic. The combustion of fuels and formation of slaked lime when water is added to lime are all exothermic. Formula: the decomposition of water into hydrogen and oxygen is an endothermic process. The decomposition of limestone, CaCO3, to make lime, CaO, is also an endothermic process. Formula: balancing chemical equations. To balance a chemical equation, numbers are placed before each reactant and product to balance the reaction. 1. Ethanol reacts with oxygen to produce carbon dioxide and water. C2H5OH plus O2 forms CO2 plus H2O. The above equation is not balanced as there are 2 units of carbon in the left and 1 unit of carbon on the right side of the equation. Hence, placing the number 2 in CO2 balances the carbon on both sides. C2H5OH plus O2 forms 2CO2 plus H2O. Now placing 3 in H2O balances the hydrogen atoms on both sides. C2H5OH plus O2 forms 2CO2 plus 3H2O. Now oxygen needs to be balanced as there are 7 on the right side. Now placing a 3 in the O2 on the left side balances the oxygen atoms. C2H5OH plus 3O2 forms 2CO2 plus 3H2O. Now the equation is fully balanced. Stoichiometric coefficients. The numbers before the atom, ion, or molecule in a chemical reaction is referred to as stoichiometric coefficients. These coefficients establish the mole ratios between the reactants and products. In the equation C2H5OH plus 3O2 forms 2CO2 plus 3H2O. The mole ratio between C2H5O and CO2 is 1:2. The mole ratio between C2H5O and H2O is 1:3. The moles can be converted into mass in grams by multiplying it with the molecular weight of the substance. The atomic mass of carbon, oxygen and hydrogen are approximately 12, 16 and 1. So the molar mass of C2H5O equals 2 multiplied by 12 plus 6 multiplied by 1 plus 16 multiplied by 1 equals 24 plus 6 plus 16 equals 46 grams. Hence 0.5 moles of C2H5OH equals 0.5 m multiplied by 46 gram, m to the power of -1, equals 23 grams. Converting grams to moles. 50 grams of CO2 is produced in the reaction. The molar mass of CO2 is equals 12 gram plus 2 multiplied by 16 grams equals 44 grams. The number of moles of CO2 produced is equals to 50 gram divided by 44 gram, m to the power of -1, equals 1.14 m.